Okay, so in this video we're going to be going over electron configuration and orbital diagrams, and I'll show you how to write out each of those. This is pretty straightforward. Compared to quantum numbers, this is extremely straightforward. And that's kind of why we have this, is because it's because quantum numbers could be a real pain to do. They're not necessarily fun, and they can be confusing. So electron configuration is a much simpler way to think about quantum placement of electrons without having to write out like a million quantum numbers. We can achieve the same outcome with a lot easier means. So basically, electron configuration is going to place electrons based on your subshells. So S, P, D, and F. And remember that these two columns here, columns 1 and 2, represent the S block. The transition metals here, going from here to here, all the way down, represent the D block. These elements over here, excluding helium, represent the P block. And these elements down here represent the F block. And remember that technically the F block goes right here, and it goes in between the S and the D block. So just some helpful hints. And this sort of tree that I've drawn over here represents how you fill up electrons. So electron configuration helps you to visualize how electrons are filled up in an atom's shells. So you start with the 1s, which is right here. So hydrogen and helium are 1s. Then we have 2s, which is right here, and then 2p, which is here, and so on. 3s, 3p, 4s, 3d. So remember that D and F don't follow the same pattern as S and P. So the first row here of the D block is the 3D, even though it comes after the 4S. So don't get confused. Just because this is in the fourth row, this is 3D. Remember, we sort of had a little thing that we used to remember that. D starts at 3. D and 3 rhyme, so just kind of say that in your head over and over again. D starts at 3. D starts at 3. Just to kind of get that into your head. So we have 3D here, and then 4P here. So we go 4S, 3D, 4P. 5S, 4D, 5P. Then we come down here to 6S, and then after 6S we have 4F. So remember that F starts at 4. You know, F and F. F block starts at 4. F block starts at 4. So we go 6S, 4F, 5D, 6P. And maybe that's when this can start getting a little confusing, but just remember, 6S, 4F, 5D, 6P. 7S, 5F, 6D, 7P. But if you can just remember that D starts at 3 and F starts at 4, you'll be golden. S and P both follow the same pattern. D and F don't. So let's take an example. Let's say we wanted to write the electron configuration of, let's say, chlorine. Just regular old chlorine. So how would we go about writing the electron configuration of chlorine? Well, basically, we're just going to write out every single electron that's in chlorine using this system. So we're going to start with 1s. I should probably write this in a different color. So we start with 1s, 2, because that's 1s1, 1s2. Those both get filled up, so we have 1s1 and 1s2. Then we go down to 2s2, which is right here and right here. We fill both of those up, keeping in mind that chlorine has 17 total electrons. So we need to get to 17. Right now we have 4. And we're going to fill all the way up over here. So we can go ahead and write in 2p6. And what I'm doing is I'm building up, starting from the lowest energy level, building up to our final electrons. And this is also part of the a new principle called the Aufbau principle. And the Aufbau principle states that you start from the lowest energy levels and you build your electrons up to the higher energy levels. Start from the lowest, work your way up to the highest. So now we have 2p6 filled up. Now we're going to come down to 3s. So 3s is going to be these two elements here. And keeping in mind the goal is chlorine, so you're basically just going through every single element up to chlorine. So we're filling the electrons for every element up to chlorine. So we're going to have that 3s2, and then we're going to have 3p. And remember, this right here is the p block. So 3p1, 2, 3, 4, 5. Just count over the elements in your block, and that's going to give us 3p5. And that's going to be the electron configuration for chlorine. So you basically just count each element going up to chlorine. And you'll want to fill the electrons as you go, keeping in mind that the S can hold 2, the P can hold 6, the D can hold 10, and the F can hold 14. And that's how you fill your electrons. Okay, let's try another example. Let's try vanadium, which is this element here. So let's do the electron configuration for vanadium. So we're going to do 1s2. We know we're going to fill up 1s2 because vanadium is element number 23, which means we're going to have 23 total electrons. So we fill up 1s2, we fill up 2s2, we fill up 2p6, we fill up 3s2, we fill up 3p6, we fill up 4s2, and now we're in the D. So we're in, remember, 3D. We go from 4s to 3D, because remember, D starts at 3. So we're going to count starting at scandium, which is our first element in this row. So we're going to count 1, 2, 3. So vanadium is 3 elements in the row, so it's going to be 3D3. And this is going to be the full electron configuration for vanadium. But there's a shortcut to this, because sometimes it can be a pain writing out all of these electrons, especially as you get higher up the periodic table. So as you get to the bigger elements in the D block and in the F block, you're going to want a shorter way to write these electron configurations. And that's why we have the shorter version, which is sometimes known as the noble gas configuration. And that's going to be the shorter way to write this. So what you're going to do with the noble gas configuration, also known as the condensed configuration, so sometimes you'll hear it referred to as the noble gas configuration, and sometimes you'll see it referred to as the condensed configuration. So what we're going to do with that is we're going to locate, so let's say we're going to stick with vanadium for right now. So let's just kind of stick with vanadium. So look at which row vanadium is on. Go to the row above that. So go to the row above where your element's at, and look at the noble gas in that row. And the noble gases are just this final column of the periodic table, group 8A. We don't really do much with them, but they are here, and they're the last column here. From helium down to ognesium, these are the noble gases. And like I said, go to the row above the row that your element's on. So vanadium is in row 4, so we'll go to row 3. And argon is the noble gas that comes before vanadium. And so how we're going to write our condensed electron configuration is we're going to put argon in brackets, because it's the noble gas that comes before our element, which is vanadium. And then we're just going to do all of the configurations up to vanadium now. So now we're going to start at argon, and we're going to go to the next one, which is 4s. So we're going to do 4s2, and 3d3. And this is the condensed electron configuration, because it basically cuts out all of this and just leaves us with the final piece. So the condensed electron configuration can be very useful for those bigger elements where you don't want to write out all of those electrons that just sort of seem pointless to write out. We can go to the row above the element that we're trying to do, and we're going to use the noble gas from that row. So you'll always want to go to the row above your element, take that noble gas, and start your configuration from that noble gas. So you would start at the next element, which in our case was potassium, and we went from potassium to vanadium instead of hydrogen to vanadium, which is the full configuration. So now let's talk a little bit about orbital diagrams. So here is sort of a blank template, which is a pretty standard template for drawing out orbital diagrams. And with the orbital diagrams, you're basically going to take your electron configuration and you're going to draw them in terms of electrons. And the way you draw electrons is with this notation. This is an up-spun electron, and this is a down-spun electron. So this is up, and this is down. And when it comes to putting our electrons in our orbital diagrams, you have to keep in mind Hund's rule, which, as we said before, you probably learned in high school as the empty bus seat rule. So electrons are kind of like people. You know how you get onto a school bus and people always take the empty seats first? And usually only when there's no more empty seats, people start sitting next to each other. Electrons are the same exact way, where they're going to fill up all the empty slots first, then they start doubling up. So all of your up-spun electrons get put, and then you can go back and do your down-spun electrons. And we kind of saw that when we were doing the quantum numbers, with drawing out all the plus 1/2 first, and then going back and doing the negative 1/2. So let's say we wanted to do the orbital diagram for, let's make it simple. Let's do fluorine first. So a somewhat more simple one. So fluorine is the 9th element, which means fluorine is going to have 9 total electrons. So 9 arrows that we're going to need to draw. So why don't you go ahead and practice your electron configuration skills first. So go ahead and pause the video and write out the full electron configuration for fluorine. And then when you're done, unpause the video and I'll put mine up on the screen and you can see if you got it right or not. So here's the full electron configuration for fluorine. So what I'm going to do is I'm going to start at 1s, because that's off-ball. Off-ball state, you have to start at the lowest energy level. So I'm going to start at S, and I'm going to put my 2 here. Remember, start with the up, then do the down. So 1s2, that gets filled up. 2s2, that's going to get filled up. Like that. And now we're at the last one, which is 2p. So we have 2p5, which means we're going to have 5 total arrows for this row. So I'm going to fill it up one at a time, starting with the up spin. So 1, 2, 3. So I've gotten 3 done, and I've gotten each slot filled up with a positive, with an upspun electron, which is in line with Hund's rule. So we're following Hund's rule. And now I've got 2 electrons left, and now I can start going back and putting in the downspun. 1, 2. So that gives me a total of 5 in the 2p orbital. So now we've got 2, 4, 6, 8, 9. 9 total electrons, which matches the electron configuration of fluorine. So hopefully that gives you sort of an idea of how to do the orbital diagrams. You just write out your configuration and just start filling in the slots with the arrows corresponding to your configuration. And make sure you follow Hund's rule. Put the up spin first, then go back and put the down spin. Let's look at one more example. So let's look at germanium. So go ahead really quick, pause the video, and write out what you think the full electron configuration for germanium is going to be. Okay, so here's the full configuration for germanium. And remember that germanium is going to be element number 32. So we're going to have 32 total electrons. So go ahead and start populating this in the orbital diagram. So why don't you go ahead and pause the video, try doing this orbital diagram yourself, and then check and see if you got it right by unpausing the video. Okay, so hopefully your orbital diagram looks something like this. So I've got all of our electrons mapped, and notice how up here I have the 2 p electrons for germanium, which makes sense because we have 4p2, so those 2 upspun electrons go in these 2 slots here because we're trying to obey Hund's rule by putting the upspin first, and then we don't have any others left, so we're just stuck with these 2 upspun electrons. So that's sort of why maybe you can see why germanium has the charge that it does. So germanium is going to have a +4 charge. So think about what germanium would need to do to complete what's going on here in terms of charge. But we'll talk about that much later when we talk more about charges and hybrid orbitals. So we'll leave that for right now. We won't really address that. But hopefully now you can see how everything goes, and hopefully you've seen a pretty good number of examples of how to A, write out these electron configurations, and B, draw these electron configurations in terms of orbital diagrams. Just keep in mind that the D block starts with 3 and the F block starts with 4. I've seen a lot of people get confused about that over the years. Just keep that in mind. D starts with 3, F starts with 4. If you remember that, you should be good. And hopefully this all helps you with the whole electron configuration orbital diagram, working with those.